Can we confirm audibility in the comment section? Someone comment if are we audible? Is the audibility? Is there audibility? Can you hear me? Yes, you are audible. Am I audible enough? All right, that's good. I get. Then, if that is the case, if you can hear me and I'm audible enough, then I'd like to officially say welcome to the first Maths Live. Yes, it's long time coming, and it was supposed to have happened quite a while back, but things happened and I couldn't officially be able to have my first session on the day that I had said I would. So all apologies to that, and to all the people that had actually geared themselves up for a lesson on that designated day. That was unfortunate, so apologies to that. I just want to say from the get-go that so the Maths channel that you guys are in, the TikTok channel, is called Maths is a Game, right? It's been in motion now at least for a few months, and the whole purpose of why the channel was started to begin with was because there was a need at the time to assist the learners that were in grade 8 and 9 with their maths preparation for the exams that they were writing in November. So I started the page initially because I wanted to help my learners in my school, and then it progressively, got to a point where I thought, let me then extend it to the purpose of assisting others, because I could see in the live sessions other people were joining. So then that got going, and it's been going okay. By extension, I've also then incorporated assisting the grade 10s and the grade 11s. All right, and I've been assisting them for the past few weeks. All right, sort of like on and off, because obviously it's festive. There's a bit of disruptions there and there, and also there's things that come up unannounced. So of course, I myself am a family man, so obviously there's other commitments that do demand my time. But when I can avail myself, I do assist in mathematics. I exclusively assist in maths, pure maths, that is. Not maths literacy, not life science, not physical science. So that's the unfortunate part. Some of you may be on here and you are hoping and wishing that I can assist you with something else. I will not be able to. I will only be able to assist with mathematics. All right. So that's just on an introductory part. All right. More information that pertains to me and everything else will come as time goes by. But for now, it's just important that the only thing I think that connects all of us is the maths, right? It's the pure mathematics for grade 12. So I'm hoping that I have on the platform those who are going to be doing grade 12 in 2025. Congratulations already that you actually have been able to go through the years of education, and you are now in grade 12 officially and finally, your last year of high school. I usually regard or consider the grade 12 year as kind of like that last and final lap, but also it's like the final race in a 100-meter race. I don't know if you guys watch the Olympics, but usually the Olympians, they go through stages. They'll go through heats, heat 1, heat 2, heat 3, and all of that stuff. They'll run quarterfinals, semis, and then the finals. So this is basically you guys running the final 100-meter race, and whatever happens in that final race will basically be what will either determine your outcome as far as opening doors in the future or closing doors. It's all dependent on you, and how you actually do what you need to do in preparation for it is important. So if you consider the date today, it's the 29th of December 2024. I consider you guys a unique group because you are congregating to have a maths lesson in December 2024. The school year will only be starting mid-January. but you guys are already eager and wanting to actually get things going. I know some of you have already started like a few weeks back. I know that personally you've already started. Some of you have started with other subjects, and I want to commend you for that. Like, I know maybe someone hasn't come to you and said to you, good job on actually utilizing your festive season and getting yourself started with your content subjects. I want to commend you. If you are in your private space already for the past few weeks, you've been doing your maths, you've been doing your physics, you've been doing your life science, you've been pretty much doing self-study using all the resources that are available on the internet and so forth. I want to commend you. You are exceptional. All right. And you know what? The only person who will benefit from your effort is you. All right. You will benefit now and you will benefit later. You will reap the rewards of that effort that you are putting in already. So I want to commend you. I want to praise you and say you've been doing a phenomenal job. Do not let up. Do not give up now, and do not tire. You know, I know festive New Year's Eve celebrations are coming up and all of that stuff, but I want to commend you for making the sacrifice. You know, I'm sure some of your friends have been going out having a good time, but you've been actually doing what you need to do, because why? You are worried about the outcome of your results come next year. Maybe some of you have been feeling a bit down in the dumps because you don't feel like your end of year grade 11 results were quite the outcome that you would have wanted. So you're wanting to really make a big difference in how you do things this coming year. I commend you for that. You must keep that up. Don't let the fire don't extinguish the fire. Let the fire continue to burn, you know, and do the most. Do your best. All right. So that's just something I wanted to say, just to sort of like on the onset, in the beginning. And yeah, I guess in as much as you guys are looking forward to this, I'm also looking forward to it. So you guys have what we call an ATP, an annual teaching plan. That's the first thing that we need to be sure that we have. Now, an annual teaching plan will give you an idea as to what are the topics that will be covered come next year, right? So for term 1, the first topic that basically, let me just say, the ATP will not be different from last year's ATP. So we are continuing basically with the same ATP that the grade 12s 2024 utilized. You'll be utilizing the same ATP. The first topic on the list is actually sequence and series, right? Number patterns, right? And you guys do first and foremost a revision on quadratic number patterns, with just an extension of quadratic number patterns as you did it in grade 11. So you start with that. And maybe some of you will be like, but quadratic number patterns was done, and in actual fact, like, I mean, that was easy. Whatever the case may be, you may feel very, diversely and differently about it. Sorry, just hang on. I'm sorry about that. So like I was saying, the first topic you guys are going to cover for term 1 is number patterns, or in other words, more specifically for grade 12, we say sequence and series, right? And the first thing that you guys do when you start out with sequence and series is you are going to revise the quadratic number patterns. Okay, quadratic number patterns, right? You remember those patterns that you did in grade 11 that basically had a second constant difference, right? That's the first topic that you guys cover, sequence and series. After that, you guys will do functions, and specifically in functions, you'll do the inverse of your functions, your inverse functions, all right? And obviously, when we get into it, you guys will see what that is all about, or when you guys get into it at school, you'll see what that's all about, okay? Then after that, you will do trigonometry, all right? Trigonometry. You will actually obviously revise all of these topics, much of what you did in grade 11, but teachers will expect that you guys have already understood the basics from previous grades. But then You will cover that, but then you will also extend the understanding that you will have established already in grade 11, and you guys will be doing double angles, compound angles, and all the other sorts that you will look at specifically. So those are the three major topics that will be covered in this term. So I repeat, it will be sequence and series, number patterns to begin with, followed by inverse functions, your functions, all right, and then lastly you have your trigonometry, all right. Okay, so please guys, on the page already, what I did do is I did do a video of picture slides, all right. The picture slides basically have I posted the ATP with picture slides of basically the topics that you'll be covering in the respective terms. So do go and check it out. I think the actual video itself has all of the terms, right? Not just term 1. So yeah, it's good to have that ATP and to have an idea of what you'll be doing for matrics 2025. Okay, then the second thing that I want to actually touch on is the utilization of a particular textbook. So on your screen you should see I've actually put as my background picture the textbook called Mind Action Series, the grade 12 mathematics textbook, Mind Action Series. All right, I have a physical copy here with me, all right, and I do know that you can actually purchase even an actual copy online if you want, so that you can actually have it on your phone or have it elsewhere. Okay, so yeah, this textbook I recommend it, and I do recommend using it personally and privately as you are preparing yourself. Go through the content and the concepts that are in the textbook so that you can equip yourself with knowledge, all right. And then secondly, also I do actually advise that when you do the exercises in the textbook, do not do some of the exercises. At school, what usually happens at school is that the teacher, after the end of a lesson, will tell you that in the textbook, in exercise 1, do number A, 1, 3, and 5. All right, and you end up missing out on the other exercises. So I will actually encourage you as a matric learner that you get into the habit of actually going through and doing the exercises, all of them, on your own. All right. So that after doing them, if you do want to, then you can actually then you can actually make sure that you get someone to mark you, your teacher or something like that. All right, I am happy to also look over some of the work that you have done. I'm happy to do that. All right, understand that yes, tons of past papers obviously work out, but what you need to do first is you need to gather the knowledge and the conceptual understanding before you jump into past papers. Past papers will be good for you once you understand the content. All right, it's very important to first understand the content and the concepts that are in a particular topic before you jump into past papers. But once you have an understanding of the content and the concepts in that particular topic, then you can move out and actually do past papers. Because remember, if you do a past paper and you actually find that you can't do a particular question, you may not be able to do that particular question. Why? Because you do not understand a particular concept that was covered in a particular topic, and therefore it makes it difficult to answer a specific question in a past paper. So the first place we need to start at a place where we can first understand the concepts and the content. Hence, I am saying to you, and I'm advising all of you, that if you do not have a working textbook that you actually are utilizing, I do suggest and I do advise and recommend that you utilize a textbook such as Mind Action Series. The new edition, not the old one, the new edition. The old edition is fine, but the new edition is updated, and there are certain things that are specifically explained simply so that you can understand those things and then be able to apply those things in your maths problems when you do them. So I am going to really encourage you to do that, all right? Also, secondly, the reason why I'm mentioning a textbook is that the place that you are going at after high school, which is university, you will find that you get given these big textbooks, right? Or these big textbooks for your different modules. And the thing is, what that is supposed to do is supposed to cultivate in you the spirit of being able to read and be well read. So you need to actually also start building that skill of reading and being well read. Right? So if you utilize the textbook, go through each and every page of that textbook from the beginning with the first topic, especially this one because it simplifies things so nicely. You go through each page, you read through the content, you try and understand what each word means and what it translates into as far as your understanding of the concept. Then you try and unpack that, and then you look at the examples. You go through each example. You try and check if you actually understand the steps that are basically in each example. And then after that, you jump into the exercise and you do the exercises applying what you have learned. Then that will actually assist you and help you in cultivating the skill and the art of self-study. People, it's an important skill that as a grade 12 learner, in fact, even as a grade 11 learner, you need to have that skill of being able to go through a body of work in a book, understand what is on there, and then be able to apply it, and so forth. Also, utilizing your dictionary, if it so be that there are certain concepts that you feel you may not understand. Or utilizing your AI engines, like for instance, you have Meta AI on your cell phone now on WhatsApp that you can actually utilize to basically ask questions related to any concept that you may not understand. And then the AI engine, what it does, it simply explains those things to you. So these are resources that you need to utilize, all right? So I do recommend this textbook, Mind Action Series. I do know as well that there's another textbook called Kevin Smith, the grade 12 Kevin Smith textbook. You can also utilize that too. Okay, so that's just on a introductory basis. I just thought a recommendation of this textbook is of utmost importance. So please guys, as grade 12 learners, I wish you all the best and everything. So let's get started. Let's get into the topic of the day. I will be ending at 2:30. All right, I'm actually going to start now and end at 2:30 because simply what I'm going to do today is go through the very first topic that you guys do cover, subtopic under sequence and series, and that is you guys actually go and do a revision of quadratic number pattern. So hopefully we are all we have our quadratic number pattern thinking cap on, and we know basically the basics of quadratic number patterns. Hopefully for those who have forgotten, you also can get your caps back on for that, all right? And then also here's another thing. Some of you please do not overlook this first section. I know some of you are already thinking of these other complicated topics that come later on in the syllabus, but for now, focus on quadratic number patterns and make sure that you can be able to do these. Sir, can you please, the activities on the group? I don't understand. Sir, can you please, the activities on the group? Okay, so like I said, this is a grade 12 lesson. First grade 12 lesson. Can you please send the activities on the group? Okay. No, that's fine. If you guys, if some of you have already done all these others, then you guys don't have to actually be in the session then. Yeah. No pressure. No pressure. And that's good. I'm glad that your teacher has covered things that far. Okay. I'm just trying to still understand this comment. Say, can you please the activities? Can you please send the activities on the group? Or you mean the ones that I will require you to do after this session? No, definitely we'll do that. Don't worry, we'll do that. I was just wondering, what do you mean by this? Can you please send, share? Okay, all right. Okay, all right. So let's get this party started. Small pizza? No, definitely not. Okay, and then those who are already in the WhatsApp group, please do somehow. Please get share with everybody else in the comment section about the group, so that you guys can get the relevant contact details. If there are people that are here that are in the group, please let others know, so that they can know how to access and join the group. Please let them know. Ne? Please let them know. All right, so let's do this. All right, so guys, here we go. So sequence and series, right? So I said we're going to look at quadratic sequences. Now remember, quadratic sequences have a general term, which is Tn. Remember this, Tn is equal to an squared plus bn plus c. All right, so if there's people that don't know the group and all of that stuff, you can send me a message, or if there's someone who is in the group, they can just let them just avail yourself in the comment section and just say I am in the group, and then they can message you on the side, even if it's on TikTok, and then basically we can share the link with everybody else that does not know about the group. Okay, all right. So that's good. I'm glad. If some of you are ahead, that's good. If you have already covered this, that's great, guys. Then you can choose not to be in the session for today. All right, it's okay. But if you feel like you are, for the first time you are here, that's fine. You can just stay. It's okay. All right, please, guys, don't feel coerced to be here. You don't have to be. So the general term for a quadratic sequence is Tn is equal to an squared plus bn plus c. Hope we can remember that. Ne? Remember that very well. An squared plus bn plus c. Now remember, if we take, let's say, term 1, t1, and substitute into the place of n, which stands for the position, what do we get as our expression on the left hand side? You take t1, you substitute 1 in the place of n, you get a plus b plus c, because 1 squared, we'll say a times 1, which gives us a, b times 1 will give us b, and then obviously c is left as that constant. All right, so a plus b plus c would be term 1 of the expression if we substituted 1 in the place of n. What about if we substituted 2 in the place of n for an squared plus bn plus c? We'd get 4a plus 2b plus c. We substitute 2 here, all right, and then we have 2 squared, which gives us 4, right? 2 squared gives us 4, so that would be 4a, plus we substitute 2 here, 2 times b, which gives us 2b, plus what? Plus c. So that means our expression for t2 will be 4a plus 2b plus c. Are we together? All right, so that is the expression for term 2. What about the expression for term 3? If we substitute 3 in the place of n, we get 9, right? 3 squared is 9. 9a plus 3b plus c. So that means we have 9a plus 3b plus c, which is an expression for term 3. Then lastly, for term 4, if we substitute 4 in the place of n, we get 4 squared, which is 6a, plus 4b plus c. Okay, so these are expressions that we get for term 1. Term 1 is a plus b plus c. Term 2, which is 4a plus 2b plus c. Term 3, which is 9a plus 3b plus c. And then term 4, which is 16a plus 4b plus c. All right. Now, if we take term 1 and term 2, the expressions as we have been given, and then we subtract term 2 minus term 1, then obviously for our first difference, we get 3a plus b. How do we get 3a plus b? Remember, 4a minus a gives us 3a. 2b minus b gives us b. And then c minus c, that's 0. So we are left with 3a plus b, which is our first term in our first difference. What about our second term in our first difference? We take term 3 of the original minus term 2 of the original. What does that give us? What's 9a minus 4a? That gives us 5a. What's 3b minus 2b? That gives us positive b. And then what's c minus c? That simply gives us a 0. What about term 3 of the first difference? We take term 4 of the original minus term 3 of the original. What's 16a minus 9? Gives us 7a. What's 4b minus 3b? That gives us a positive b. And then lastly, what's c minus c? That gives us 0. So I'm sure you can see that our first difference expressions for first term, second term, and third term are respectively 3a plus b, 5a plus b, and 7a plus b. Now let's take it further and get the second difference from the first difference terms. So let's look at this. What if we took term 2 of the first difference minus term 1 of the first difference and subtracted? That means 5a minus 3a gives us 2a. What about b minus b? That gives us 0. So that means we are left with 2a as our second difference. Let's look at the third term and the second term of the first difference and subtract and see what we get. What's 7a minus 5a? We get 2a. What about b minus b? We get 0. So that means we have 2a in our second difference as well as 2a for our second difference for both the first term and the second term of the first difference and the third term and the second term of the first difference. So that means our second difference is actually what? It is constant. The second difference is constant. Right? I hope you guys can see that. All right, our second difference is constant. All right, and it's given by 2a. All right, so this is something that you guys should have learned in grade 11. All right, because this concept here of the first term of the original sequence, the expression, if we substitute t1 in the original quadratic general term being a plus b plus c, all right, and all the other terms, this helps us to be able to know what to do whenever we are required to find the general term of an actual given quadratic sequence. So let's look at an actual given quadratic sequence. Okay, so we have 5, 10, 20, and 35. This is a sequence that is, as we call it a quadratic sequence. All right, and I'm just going to go into the definition of what a quadratic sequence is shortly, but first and foremost, let's just look at this example. So 5, 10, 20, and 35, this is called a quadratic sequence. Okay, now if we find the first difference of each of these terms, what's 10 minus 5? We get 5. What's 20 minus 10? We get 10. What's 35 minus 20? We get 15. So our first difference is 5, 10, 15. What kind of sequence does our first difference of a quadratic sequence give us? Our first difference gives us a linear sequence, or in other words, we call it a arithmetic sequence. So I'm going to use AS to basically denote a linear sequence, or what we refer to as a quadratic sequence. You guys learned what a linear sequence is in grade 10. No? A linear sequence is the kind of sequence that has a first difference that is constant. So what a quadratic sequence does, it actually forms a first difference that is linear. Alright, and then if we look at the second difference of a linear sequence, of the quadratic sequence, we actually get a constant difference. Right, so what's 10 minus 5? We get 5. What's 15 minus 10? We also get 5. So this here, 5, 10, 20, 35 is a quadratic sequence. How do we know it's a quadratic sequence? It's because its first difference gives us a linear sequence, but then the second difference is constant. All right, in other words, meaning the second difference is got the same value. All right, the first difference is going to be a linear sequence for a quadratic sequence, but the second difference will be constant. It will give us the same value. That's what the word constant means. It means we get the same value for our second difference. All right, so if we give a definition, what is actually a quadratic sequence? A quadratic sequence is simply this, is a sequence whose second difference is constant. A quadratic sequence is a sequence whose second difference is constant. Okay, hopefully we are all in the same page, people. A quadratic sequence is a sequence, or in other words, a sequence is just a list of numbers, all right, that's consecutive, that's placed consecutively one after the other. So a quadratic sequence is a sequence whose second difference is constant. All right, so if we go back and look at the example, why do we say this sequence is a quadratic sequence? It's because if we look at the first difference, do we get constant values? No, we don't. 10 minus 5 is 5, 20 minus 10 is 10, 35 minus 20 is 15. The first difference is not constant, but the first difference gives us a linear sequence. And we'll learn later on that the other word that we can use for a linear sequence is something that we refer to as a arithmetic sequence, right? Linear sequence is familiar to us because we did that in grade 10. And we learned about it in grade 9, all right? We even did it in grade 11. So linear sequence is something that we know, but the word arithmetic sequence may be new to us, but we will also introduce this particular concept of arithmetic sequence. But if you look at this arithmetic sequence, what it gives us is a constant difference. So basically our quadratic sequence is truly a sequence whose second difference is constant. We could even say its first difference gives us a linear sequence. So there's two things here that we are learning about a quadratic sequence. A quadratic sequence will give us a first difference that is linear, or in other words, that is arithmetic in nature, but then its second difference will be constant. All right, that is what a quadratic sequence is, all right, by definition. So let's jump in now and go in and find how do we then determine the general term, in other words Tn. This word general term simply means Tn, or it means the general formula of the sequence, or it means the nth term. How do we determine the general term Tn of the sequence 5, 10, 20, and 35? So the way that we do that is we actually go back and we utilize these expressions that we had gotten when we were still finding the expressions of T1, T2 from our actual general term an squared plus bn plus c. All right, so we are going to use these expressions. Term 1 is a plus b plus c of the original sequence. 3a plus b is the expression that we use for the first term in the first difference, and then 2a is the constant expression that we use for basically our quadratic. So we are going to utilize a plus b plus c, which is t1, 3a plus b, which is the first term in the first difference, and then 2a. We're going to use these three expressions and get the general term of this specific sequence 5, 10, 20, and 35, which is a quadratic sequence. So how we are going to do that is in the following way. So remember that this 5 is standing in the place of a plus b plus c. Do we remember that? Okay, so that means a plus b plus c is equal to 5. This 5, which is the first difference of this one here, stands in the place of 3a plus b. So 3a plus b is equal to this 5. Then this 5 is standing in the place of that 2a expression, which is 2a then means it's equal to 5. But I'm sure you guys can see that 2a is equal to 5. We can solve something and get a here. For this expression, we have two unknowns, which means we can't do anything yet. A plus b plus c, this expression has three unknowns, which means we can't do anything yet here. So for these two, 1, 2, we can't do anything yet. But here, 2a is equal to 5. We can definitely solve for a, or the unknown here. So we first write down the expression 2a is equal to 5. Remember, where does this 2a come from? It comes from the fact that we know that generally speaking, for an squared plus bn plus c, when we get the second constant difference, we get 2a. Right? So we take 2a, we equate it to the value of the actual value of the constant difference, the second constant difference. So what's 2a is equal to 5? Let's solve for a here. What do we do when we're solving for a? We take the 2a is equal to 5. We want to solve for a, we divide both sides by the coefficient of a, which is 2. So when we do that, we get a is equal to, remember that 2 divided by 2, that means 2 becomes, basically 2 divided by 2 becomes 1. The coefficient becomes 1 here, 1a. Then on the other side, we divide by 2 as well. What's 5 divided by 2? It's 5 over 2. So the value of a is equal to 5 over 2. So we've gotten the value of a. A is in the bag. We move on to the next expression. 3a plus b is supposed to be equated to 5, which is the first term of our first difference. What's 3a plus b is equal to 5? Okay, we say 3a plus b is equal to 5. Then we substitute the value of a in the place of a. Remember, we got a is equal to 5 over 2, which means in the place of a, we use brackets. We substitute 5 over 2 in the place of a, right? For those who are joining in, this is grade 12. It's not any other grade, so it's grade 12. So we say 3, then in the place of a, we substitute 5 over 2 plus the b, which is equal to the 5. Then we solve for b. When we solve for b, obviously board mass comes into play. 3 times 5 over 2 gives us 15 over 2 plus what? Plus b, which is equal to 5. So now we have 15 over 2 plus b, which is equal to 5. Then what do? We transpose, or we take the 15 over 2 over to the other side, because 15 over 2 is added to b. So we can take 15 over 2, transpose it to the other side. It becomes minus 15 over 2. Then we can simply use our calculator here. We don't really have to do this thing of actually subtracting and LCD and stuff. We can just simply use our calculator. 5 minus 15 over 2 gives us negative 5 over 2. And then b is equal to what? Negative 5 over 2. So we've gotten the value of a, we've gotten the value of b. Now we only need to find the value of c. So then we go to our last expression, a plus b plus c, which was equal to 5. It was equal to the first term of the original sequence. Then we say a plus b plus c is equal to 5. Then remember what was a? A was 5 over 2. So we substitute in the place of a in brackets 5 over 2. What was b? B we found is negative 5 over 2. So we say plus brackets, we substitute negative 5 over 2 in brackets, plus c, which is what we are trying to find, plus c, which is equal to that 5. Right? So we are very close to getting the value of c, guys. Very, very close to getting the value of c. Now, to finish this problem off, okay, this is very blurry. I don't know why my phone is going blurry all of a sudden. Okay, there it goes. Okay, returns 5 over 2. Positive times a negative gives us a negative. So that means 5 over 2 minus 5 over 2, which is 0, plus c. Now 0 plus c leaves us with just c. C is equal to, on the right hand side we have 5. So do you see, guys, how we found the value of a? We took a, we substituted it into the expression 3a plus b. We found the value of b. We took a and b, went and substituted it in the expression a plus b plus c, so that we can find the value of c. C is equal to 5. And all along we utilized our algebra that we've learned in earlier grades. And this is what I love about this topic being the first topic for the year. It gives a grade 12 learner an opportunity to get back into the swing of things as far as the algebra is concerned, because we need to know how to utilize the algebra to get our answers. So then we can conclude here now. Remember, the general expression for a general term was Tn is equal to an squared plus bn plus c. Do you remember that? But we needed the value of a, the value of b, the value of c. We now have those values. A was 5 over 2. Now we can substitute in the place of a 5 over 2, followed by n squared. So 5 over 2 n squared is our first term in that general term, followed by plus what? B. What was the value of b? B was negative 5 over 2. So in brackets, we put negative 5 over 2 followed by the n, plus our c value. What was the c value? C was 5 plus 5. Then algebra comes into play. 5 over 2 n squared, positive times a negative gives us a negative. 5 over 2n plus what? Plus 5. That is our general term. The general term of the quadratic sequence is Tn is equal to 5 over 2n squared minus 5 over 2n plus 5. Beautifully well done. That is how we find the general term of a quadratic sequence, as we had learned in grade 11. Revising it again in grade 12, because in grade 12, when you start, you do this as well at the beginning of the year. All right. So, any questions, guys? Anyone who has any questions about anything I've covered here, right? If you've just joined in, then of course you're going to have a lot of questions about what did I do, what happened, where did it happen, and so forth. Okay, all right. Just wait a minute, wait a sec. The next question that we need to quickly look at under the same question, which is a sub question, it says calculate the value of T12 or term 12, or calculate the 12th term. All right. So when they say calculate the what? The 12th term. The 12th term. All right. That means we need to substitute in the place of what? Of n, the value of 12. We need to substitute in the place of n 12, right? So what you then do is you go to the formula that you had just gotten. Tn is equal to 5 over 2n squared minus 5 over 2n plus 5. You substitute in the place of n the value of 12. So you're going to say T12 in the place of n is equal to, then where you see the n, you are going to substitute the value of 12 in brackets. We utilize brackets whenever we substitute. Why? Because brackets would then imply that if something is next to something else in this bracket, it means we need to multiply. Okay, so 12 in brackets raised to the power 2 minus 5 over 2 brackets, you have your 12 plus what? Plus 5. And then simply put, all you can just do, which makes life very easy, you just take your calculator, you grab it, you put what you've just written. 5 over 2, you have your brackets there, you have 12, you close your brackets, you square it, that's minus, you have 5 over 2 again, minus 5 over 2, alright, your brackets, 12, you close them, plus what? Plus 5. Okay, so you just punch that all into your calculator and you say equal, and then your calculator will give you the answer, 335. Okay, okay, and then you put that in there as your answer. Okay. All right. And then the very last question underneath the same question says which term in this pattern is equal. So which term in this pattern is equal to 497? Which term in the pattern is equal to 497? This is quadratic. Which term in the pattern is equal to 497? So for this particular question, because you need to check the question, what the question asked is. So the question being asked here is we need to find, if they're saying which term, they want us to find the position, all right, of that particular value of the term, which is 497. We need to find the position. So what we do with this question is we take Tn, which we just found, and equate it, all right. So they're saying which term in this pattern is equal to 497. Okay, so then what we do is we take Tn and we equate it to 497. Actually, let's do this, guys. Which term is equal to 955? So which term in the pattern is equal to 955? Okay, so if the question was saying which term, I repeat, which term in this pattern is equal to 955? Which term in the pattern is equal to 955? Okay, so then what you do is you take that general term that you've gotten, which was your first question. Remember, we found the general term, Tn. You equate it to the value of the term, which is 955. And what we want to find is the position. In other words, we want to find n. Okay, we want to find n, the value of n. So we write down Tn, which is 5 over 2n squared minus 5 over 2n plus 5. Remember, that was the general term, okay, Tn. Then we equate it to 955. Okay, so you take the general term, you equate it to the value of the term, which is 955. Then from there, you can solve for n. Now, every grade 12 learner should be in the position of solving this particular equation, all right? And that is why I was saying that this topic is a very important topic, because it helps you to be able to establish those concepts that you had covered in grade 11. It gives you a chance to revise those concepts again, so that you can check that you can solve for an unknown variable, you can solve a quadratic equation, you can do all these things that are important for you to be able to do as a grade 12 learner. So I am saying, I'm going to repeat the question. The question says which term, remember when they say which term, they want to know the position of the term. Which term in this pattern is equal to 955? 955 is the value of the term, but we want to know what? The position of this particular value of this term. That's what we want to know. So what we'd have to do is we'd have to take the general term and equate it to the value of the term. Okay, so then you take that the general term, which is 5 over 2n squared minus 5 over 2n plus 5. You equate it to the value of the term, which is 955. Then from there, what do? You solve for n. Okay, now I don't think I should be explaining to you how do we go about solving for an unknown as a grade 12 len. But if it is that I need to be explaining to you how to solve for an unknown as a grade 12 len, then it means that you need to do a serious job of revising your grade 11 work and making sure that you are in the position of knowing how to solve a quadratic equation. Because at this stage, all grade 12 learners should know how to solve a quadratic equation. If you can't solve a quadratic equation, it needs you to revise it, must revise it, right? So then what you would do is you would transpose 955, okay, or depending on you could take this equation and find what? The LCT. Because you can see most as a denominator, there's 2, 5 has a denominator of 1, 955 has a denominator of 1 if you were to write the actual denominator. So what you do first, you find the LCT. In this case, it's 2, right? You multiply left and right every term in the equation. You multiply every term by 2. Okay, so if you multiply by 2, then you are left with 5n squared minus 5n plus 10, which is equal to 1910. You transpose the 1910, you get minus 1900. You can see there's a highest common factor of 5, you divide by that. You get n squared minus n minus 380. Okay, if you use the quadratic formula, remember that you need to first get the equation into standard form before you use the quadratic formula. You could also use that, but first you need to get the equation into standard form. Then you can utilize the quadratic formula if you so please, all right? Because that is a tool that you can utilize. So here you divide by 5, the highest common factor. You get n squared minus n minus 380, which is equal to 0. Then you can actually factorize this, all right? Okay, remember factorization of a trinomial. Okay, the factors are 20 and 19, negative 20 and positive 19. But if you use a quadratic formula to make life very easy for you, it will be straightforward. So you can use the quadratic formula. At the end of the day, you'll get two answers. N is equal to 20 or n is equal to negative 19. We reject the negative answer because can a position be negative? I mean, even if you have athletes, right, running a 100-meter race, do you ever have someone coming in number -7 or number -5 if you are referring to a position? No, you wouldn't, right? So the position here obviously would be n is equal to 20. Okay, that number 955 is actually occupying the 20th position of your quadratic sequence. So it's term 20, right? So this one is out. N can never be negative 19, but n is equal to 20 only. Why? Because position is a natural number. What is a natural number? It's a number that starts at 1, it increases by 1 all the way to infinity. So natural numbers are what we refer to as positive numbers from 1 onwards, okay? So T20, the position of 955 is its term number 20. That's what it is. Okay. So guys, I'm gonna hold it right there. Okay. I'm gonna hold it right there. So that was basically the session for today. Well, I'll hold it right there. Thank you so much for joining. It was nice for you to join. I'll see you at another time. Please, to those people that still need to make sure that they are able to join that group, they can join it, and then communication will actually fall on there as to when again and when. But yeah, that is the session for today. Thank you so much. It was good. So please, guys, utilize the textbook, and then those who don't know about the group, you can just send one of the members a message, or you can send me on TikTok here. You can send me a message and I'll send you the link. Okay. Yeah. You can also inbox Junior. I think Junior there is also availing himself for assistance and help. You can actually inbox Junior for the link and he can get it to you. Yeah. And then what I'll be doing as well is I'll be forwarding some exercises that you guys can do around this particular concept that we've just covered. All right, yeah, so that you can check if what we did today is actually making sense and you can do it on your own. Okay, thank you so much. Cheerio, toodles, goodbye.